Yes, this is the first one in chapter 4. So we are going to do 4.1. I just didn't like the way they did it in the book, so I'm switching them around. Okay? Yes. So some of you guys already know that if I don't like the order of the book, I'll just start switching stuff around. So I think in algebra we did part of chapter 1 and chapter 10, and I mean I just moved stuff around where I think it should fit better. So we're doing this one first. Graphing quadratic functions in vertex or intercept form. Yes. Everyone done? Okay. Yes, it is. I know. I hate the goals of this book. They're really bad. They're the same as the title. No, I add the to solve. It says something like you will do blah 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 blah, and I kind of cut it out a little bit, change it a little bit, make it more simple. And I actually didn't put the y in here today because I forgot this morning. I know, but it's in your book at the beginning of chapter 2, 4.2. No. Why? Are you done? Yes, honey. Nope. We're talking about x-intercepts. Okay. When it says intercept form, ladies and gentlemen, they are talking about x-intercepts, not y-intercepts. Okay? With quadratics. Everyone good? All right, here we go. Okay, so we have two key concepts, and I didn't cover up the little things underneath the key concepts, but just have to deal with it. Our first key concept is vertex form, and you've seen this twice before. Yeah, well, once that we've talked about. Okay, and it looks like this. Y equals A times X minus H squared plus K. Okay, and the last time we saw it, it was in absolute value form, right? Almost exactly the same thing. What is wrong with you? So what is my vertex? Who can tell me what the vertex would be from this? HK. Good. Right? Where H is my X and K is my Y. This was the first sheet we did. I've done two of them, so it wasn't the one yesterday. It was the one before this. Okay. My axis of symmetry is going to be X equals what? H. Good. X equals H. Good. Okay. And my parabola opens up when what? When what's positive? Yeah, A, right? When A is positive, it opens up. Good. And it opens down when A is negative. Yeah, good. Perfect, right? We did that. In the one exploratory one that we did before this that looks exactly like the one you did yesterday, except had different problems on it, right? Yeah, it is. This is what you were supposed to discover on your own. Maybe not this formally, right? But you're supposed to be able to tell me that this is the vertex, this is my axis of symmetry, and it opens up or down, which almost all of you can do. Okay? The one we worked on yesterday is called intercept form. Okay? And it takes the form of y equals a times x minus p times x minus q. And my intercepts are what? P and Q. Very good. P and Q. They're always, because these are positive and these are negative, we always switch them, right? So if they're negative in here, my P and Q would be positive. If they're positive in here, my P and Q would be on the negative side. Yeah. So it's the opposite always. Good. And my axis of symmetry is a little different. How did you have to find the axis of symmetry? Once you had your vertexes yesterday, right? How'd you find your axis of symmetry? What was it? It was halfway between P and Q. So mathematically, we can write that as P plus Q divided by 2. And that's my axis of symmetry. Right, you should notice that it was the axis of symmetry happened to be halfway in between. And if you need to find the vertex, what you do is you take the number that you get here, plug it into your equation, and that way you don't have to solve for one problem, and then you get your vertex, where the vertex is. Okay? And we'll do that in a problem in a few minutes. Okay? And it opens up when what? A is positive. Good. Just like the other one. And it opens down when A is negative. Yeah. So that part stays the same. Great. Nice job, ladies and gentlemen. That's it. Don't know. Higher than you guys? 30 something, I think. Everybody in class knows what you got by now, so I don't know why you keep trying to lie. Okay. Is everyone ready? Not yet? I can change your grade so you got a 5 out of 50. Okay. So now we're going to graph the function. These directions come directly from your homework. Okay, so this is exactly what you're going to do. You're going to graph the function, label the vertex and axis of symmetry. Okay? So what form is this in? Vertex form. Great. Wait till everyone gets the problem written down. I will pause for a moment. Okay, so what is my vertex? Two and 4. Okay, we change this one, and this one stays the same. Okay, lovely. So open up or down? go over 2, up 4. Oh, really? Yeah, that's my vertex, 2, 4. Okay. What does the negative 4 out front say? Yeah, opens down, but what else does the negative 4 do? It stretches it out, right? Yes, this is a vertex form. This is what we did on the first time we did this exercise, not yesterday's. So the negative 4, although yesterday with the number on the outside, it still does the same thing. Normally we go over 1 and down how far? 1 squared, right? We go over 2 and how far down? 2 squared over 3 and down 3 squared, right? But what does that 4 in front mean that happens? That's the pattern to get from this point to the next one. Over 1, down 1 squared. Over 2, down 2 squared. We did talk about this. It doesn't make it wider. It makes it, yeah. I'm trying. You have to draw this. To get to every point on a parabola, this is what you do. Unless there's something up here, like a number. Okay? So if that 4 wasn't there, I would go over 1 and down 1. Over 2 and down 4. Over 3, down 9. 3 squared is 9. Yes. Okay. Please listen, guys. Okay. When we make a parabola, let me fix this. A parabola, that's the U shape. Okay. When I make a parabola, right, I go over the parent function says y equals x squared. I'm going to do it downwards since my graph is downwards. Okay, to get to, if I go over 1, if I plug in 1 for x, I get negative 1. If I plug in 2 for x, what do I get? Negative 4. I went over 1, down 1 squared. Over 2, down 2 squared. Okay, right, 2 squared. Okay? And so this is my normal parabola. Okay? This is not quite normal because of why? It has a 4 in front of it. So what you have to do is take these numbers on the downward and multiply by 4. That's all. And if you would remember 149. Yeah, so I'm going to go over 1 and down, not 1, down how far? 4. And over 2 and not down 4 times. There you go, down 16, which I don't think I can go down 16 on this graph, okay? Yeah. Oh, that was lovely. Okay, so if I can't make 16 on my graph, I'm not going to do it. Did that answer your question? Okay. If there's not a number out front, you're just going to do the normal. Down over 1, down 1, over 2, down 4, right? Okay. Everyone okay with that? Okay. Where? You got where it opens down at? Normally I go over 1 and down 1, right? But this time I have to multiply by what? 4. Just 4, because I already know the negative just means it's opening down, right? So I'm going to go over 1 and down. Instead of going down 1, I'm going to go down, because 1 times 4 is, that's all we were saying. 2 squared is 4, right? So if I went over 2, I go down 4 times 4, which is, what? Yes. 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 Correct. So this is a pattern, right? Okay, guys, please listen. I think people are getting confused when I say 2 squared and 3 squared, because everyone's okay, like I go over 1 down 1, over 2 down 4, and you are okay with that, right? But if you see it's a pattern, over 1 down 1 squared, over 2 down 2 squared. Whatever I go over, I go down that many squared. So if I go over 5, I'm going to go down 5 squared. That's all that is. It's just a pattern, right? That's right. And then if there's a number out front, I'm going to take that pattern and multiply it by that number. That's it. Because I was trying to explain this is the normal parabola, right? And sometimes they may ask you to compare it to this one, and what is it? It's narrower. Remember we talked about that? Yeah. Okay. Everyone okay with that? Is that better now? Okay. All right, so let's do this one. Now this is what we did yesterday, which is intercept form. Do I know what my vertex is? In intercept form, do I know what my vertex is? No, I do not know what my vertex is. But I do know what my what is. My intercepts are, right? My x-intercepts. They're on the x-intercept. It doesn't matter which one's which. I don't care which one's P or Q. I just know they're on the x-intercept, right? They're on this one. Go ahead. Did that answer your question? They're two different, right? The form is different. Oh, thank you. Sorry, you guys, we needed to label these. Okay? My vertex is here. You just put a point and you label it. What is it? 2, 4. And my axis of symmetry is a dotted line that goes right through the, yeah, and it's x equals 2. Yeah, that's all. Okay? Thank you for reminding me about that point. Okay? So they just wanted the vertex and axis of symmetry on this one. Great. Yeah. Okay. So what are my x-intercepts? -2 and -6. Good. These are all changed. Yes, good. When they're inside the parentheses, they change. Okay? So my x-intercepts are at -2 and -6. So if I'm going to label them, I'm going to put -2, 0, and -6, 0, right? I did go down 0. No, these are intercepts. They're where they cross the axis at. There's two different intercepts. Okay? Now I need to find my axis of symmetry. Yes. Doesn't it say label? And how do I find my axis of symmetry? We talked about it earlier in our notes. It's half of these. I'm going to add these and divide by I'm going to find, basically it's finding the average, right? You add things together and divide by 2. I'm going to find the average. So negative 2 plus negative 6 divided by 2 is what? Negative 4. And that's x equals, so that's my axis of symmetry, which goes right through here. Right? There's one other thing we need to find to graph the parabola, and what is that? The vertex. How am I going to find my vertex? Yeah. I'm going to take my negative 4, and I'm going to plug it in. That's the only way to do it. You have to plug it in. Yeah. You plug it into your equation wherever there's an x, right? So 3 times, what's negative 4 plus 2? Negative 2. Oops. Times negative 4 plus 6 is 2. Negative 4 plus 6. 6 minus 4. 2. Okay? So 3 times negative 2 is, times 2 is negative 12. So I'm going to go negative 4 down 12. 2, 4, 6. Ah! Okay, 2, 4, 6, 8, 10, 12. I'm going to go by 2's down here. This is negative 4, negative 12. That's my axis of symmetry. Okay? And my vertex is always on the axis of symmetry. Okay? The vertex is always on the axis of symmetry. No, you don't necessarily have to have 5 points. I would probably pick somewhere in between here, between negative 12 and 0. Okay? Yes? And put the negative 4 here. You put the negative 4 in both places. Yes. Just like we did yesterday when you were making the table? Exactly. Okay? I guess I need to label that, right? Okay. Everyone okay with that? That's exactly what we did yesterday, and hopefully by the end of the 18 problems you were able to do that. That's what I wanted you to find yesterday. Okay? Instead of having to do 18 tables. Okay? Much simpler to do that way. And I know that some of you were able to find that. Okay? One more slide and we're done. No graphing this time. Okay? One more. We have 2 problems to do, but no graphing. Last slide. Okay? And I think you guys should be able to do this because this is basically what we did in the warm-up. Okay, we want to write it in standard form. So I need to get rid of the parentheses. So I'm going to distribute. And I know some of you know it as foiling. I never use foiling because people get confused. It's distributing. That's all we're doing. Okay? So I'm going to distribute x times x is what? X squared. X times 3 is when you add them. Yeah, when we multiply it's squared. When we add it's 2x. Okay? And then negative 5x times x is, and negative 5 times 3 is, okay, great. Combine my like terms and I get y equals x squared minus 2x minus 15. That's it. This is the easy part now. Yay. Yay. easy. I distributed. I distributed the x through, I distributed the negative 5 through, and then I combined my like terms and wrote it in standard form. Okay? All right, a little bit harder one. Can you guys, okay, I'm going to let you guys work on it for a few minutes before I do it. Remember what squared means. Just throwing that out there to you. Yes. They're going to get a random yes in the middle of the recording and be like, what did you say yes for? Now we're only going to do this in standard form just right now. Okay? Only when they ask us. You don't have to distribute it out because we don't know how to graph them distributed it out yet. That was what chapter 1 was. So. I'm not going to do the whole thing. I'm just going to write this out. Everyone at least get that part right? Well, if I'm going to do this, I'm going to do my parentheses first. I'm going to do this part first and then distribute the 5 through my answer. Okay? So here I go. X times x is x squared. X times 3 is 3 times x is, and 3 times 3 is, and then minus 4. Then I get 5 times x squared plus 6x plus 9 minus 4. Now I'm going to distribute my 5 through, right? So 5x squared plus 30x plus 45 minus 4. So the final answer should be 5x squared plus 30x plus 41. Right? Shoot. This one's a little more complicated and involved, right? But it's still not too bad. It's just straight algebra. Okay? I guess I should have it y equals. Okay? You guys are going to do other ones. And there's examples in your book. 5 times 9 is, yep. Yeah, because they're the only like terms. This doesn't have an x, right? So I'm only going to subtract my constants. Okay? Erin, any other questions? Or are we good? Okay, great. So we graphed functions in vertex form and intercept form. Great. And there's your homework. It's 22 not even 20, 21 problems. 21. Because I started at problem 4, not problem 2. 249. 4 through 40 even, 23 and 50. And 50 is a challenge question. Please try. It's kind of like a proof, which all of you have been in geometry, so you should be able to do it. And you've got about 40 minutes, 30 minutes to work on your homework.